Hello everyone, my name is Vladimir Shimovic and I am a lecturer from Zagreb University of Applied Sciences in Zagreb, Croatia. Today I'm going to be presenting you a paper that I co-wrote with my colleagues Vatroslav Zupa Bakša and Tomislav Đuran from the same aforementioned university. The name of the paper is "A Learning Management System as a Tool for Online Knowledge Evaluation in an Engineering Course During the COVID-19 Pandemic." So, let's get started. Technology has always been a part of the educational process one way or another, whether we are talking about using computers in education directly or just using PowerPoint during our presentations. During the 2019-2020 academic year, because of the disruption caused by the COVID-19 pandemic, a large and an unplanned shift to using technology for education online occurred. While most of the lessons could be adapted online through use of streaming applications, presentation software, and aided by the use of the graphic tablets, the main disruption happened in testing. Suddenly, students and teachers were not in the same room while knowledge was being evaluated, and this posed a serious challenge to institutions and individuals that were accustomed to proctored testing. This paper examines the role of learning management systems used as a tool for online knowledge evaluation in an engineering course named Fundamentals of Electrical Engineering at the Electrical Engineering Department of the Zagreb University of Applied Sciences during the COVID-19 pandemic. Fundamentals of Electrical Engineering is a first semester course that acts as an introduction to electrical engineering for students. The course is spaced through 15 weeks, which is the duration of a single semester. The course itinerary can be seen on the table on the slide. Course examinations during their semesters are done through 3 midterms, usually at week 7 and 15. While an additional midterm is held at week 16. During the 2019-2020 academic year, all 3 midterms were held online, using Moodle as the learning management system of choice. Moodle was chosen after considerable research. Each of the midterms consisted of 8 calculation problems. The examination for each midterm was split in 2 parts, with one part consisting of 6 shorter calculation problems, while the other 2 calculation problems formed the second part of the exam. The idea was the other 2 were a bit more complex and had more sub-questions. The whole midterm examination lasted 120 minutes. 60 minutes was given for each part. The split happened because we wanted to curb technical issues, so we split the examination in 2 parts, so even if we had technical issues midway, we still had some data or something that can act as a backup. Also, the split was done to curb cheating. We did not want to have students have access to the whole exam at once, even though we had other methods to curb cheating in mind that we'll talk about later. The main challenge in online knowledge evaluation is keeping the outcomes the same as in an offline proctor knowledge evaluation setting. When thinking about online testing, the biggest emphasis had to be put on curbing cheating. But also, while having that in mind, we had to think about possible technical challenges for students and also for the teachers and our system. So, 267 students took the first online midterm exam. They were not required to have a microphone and or camera, mainly because of our inability to monitor such a large number of students all at once. Also, there was a concern for the stability of the streaming platform MS Teams due to the increased bandwidth. Even if all 267 students took the exam at once, that doesn't mean the system cannot be overloaded by another exam in parallel from a different course. We are a large university. Also, some students may not have a camera on their laptop or a computer, or may experience technical difficulties with their microphone and or camera. One of the largest student concerns when talking about online knowledge evaluation was the newness factor of the online tests. Students and teachers were in a way forced to be early adopters of such a knowledge evaluation procedure. This was mitigated by a mock midterm exam 2 weeks earlier that proved to be a great opportunity to test all the functionalities of the system for the users on both sides of evaluation. A total of 187 students attended the mock test and it proved to be a success. Let's talk about question procedure. In the first part of the exam, each of the 6 tasks was awarded 10 points, and in the second part, each of the 2 tasks were awarded 20 points, which gives a total of 100 points. The exam was scored by the system and there were no negative points. Students were expected to make calculations and, with typing in solutions, type in correct results with the appropriate units of measurement. The system can recognize all different types of measurements. So, type solutions without the correct unit of measurements were evaluated with 0 points. Also, each task of 8 of them was given in 4 variants with randomly generated numerical values, and the task schedule was given in random order with free navigation throughout the questions. This was done in order to curb cheating. So, in theory, students could be communicating through something like Discord, but they couldn't easily talk about their tasks, because let's say a sentence, "Can someone help me with the 4th question?" doesn't mean anything to anyone, because they're all in random. They have variants and also they have random numbers. The variants are similar, but still different enough so they couldn't help each other very fast. Also, to avoid scoring on the principle of true-false and to implement gradual partial scoring, we implemented also the fact that each task had several sub-questions that led to the final result. So you could actually get 60% of the points from certain tasks. Also, to curb cheating and again get partial scoring, students were obligated to upload a PDF of their handwritten results. So when we had the case of students saying, "Oh, I got 0 points, but I got the question correctly, but I read the initial question a bit wrong, so I started with a different number, but had the whole procedure right," we would give him partial points. The system is unable, of course, to automatically partially grade such a student, but that's why we meet with the students a day after the results were published. An example of one of the 4 variants of one exam task from the first part of the exam is given on the slide. In the given network, students were instructed to determine the total resistance of the network and the instrument measurements. An example of supply starting data would be 3 volts for the source, and the resistors would be 1910 ohms, and the R5 would be 16 ohms. Students are expected to type the final solution into the response interface that you can see on the bottom of the screen. The solution should contain a numerical value and a unit of measurement. Clicking on the orange root icon in the interface shown on the figure opens a new interface for students to type fractions, write the result in a scientific record, or add prefixes in front of units using symbols, etc. And the system recognizes all equivalent to the correct solution. An example of a variant of this type of task would be, for example, just moving the ammeter or the voltmeter through the network, or just maybe replacing some of the resistors. If I remember correctly, one of the variants included putting the voltmeter in series with the R2 resistor. So the calculations would be similar, but since it has an infinite resistance in that line, the answers would be pretty simple, but still different enough for the students not to get the difference between their tasks, so they couldn't actually help each other among themselves. On the slide, you can see an example of programming of one of these variants of tasks. You can see that the first three variables, the source, the resistor 1 and the 2, were randomized, while intentionally the third one and the fourth one were not randomized. The fifth one was randomized. So for some of you who remember electrical engineering, this actually results, this is a Wheatstone's bridge, and we actually made it in balance. So there's no voltage or current going through the R5 resistor. So we could put random variables, but we knew exactly what the solution was. So the electricity through the ammeter is very easy to calculate. You just needed to find out what the total resistance of this network was, while the voltmeter was always 0 volts. Of course, this can be done differently, but this was just to show you in a short example of a question and its programming. On this slide, you can see a figure where for the said question before said task, we here now define three variables that need to be inputted, and those are connected with the programming before, where we define what has to be inputted. So the three variables are the total resistance, electricity through the ammeter, and the voltage on the voltmeter. Also, we define their measurement units: ohm, ampere, and volt. Also, we define here what the distribution for each answer is. So here it's 40% for the total resistance, 30% of the grade for the electricity through the ammeter, and 30% for the value of the voltmeter. So this is how we define the answers and how we grade them. Also through defining validation and variables and preview, we can also define other things like the tolerance for the exact answer. We tolerated only 1.5% deviation from the correct answer, etc., etc. The tool that made all of this possible for us is, as you can see at the bottom of the figure, is Virus. Actually, like Virus quizzes. With it, we were able to program these things much more easily, and actually like define much more subtasks. For example, as I said, this task has 3 answers, so we could partially grade it. Other than helping us form exams and tasks for them and partially grading them and hopefully curb some cheating, the virus quizzes also helped us to analyze data. We could analyze average points on every question. We could go into some different types of markers like discrimination index and discriminative efficiency that I'm not going to go into this presentation because it's a long dive. So what we could do, we could see which questions were harder for students, so we can analyze which part of the course materials were better adopted or less adopted. From an institutional perspective, shifting student online knowledge evaluation was a necessity. We had to do it. From an educational point of view, it represents a successful shift to an unproctored type of knowledge examination that opened up a wide array of possibilities for data mining. This is also an opportunity for us to do some research. We plan to do more of it. There's a potentially interesting comparison of proctored and unproctored offline and online knowledge evaluation that can be made when examining the success rates of students that have failed the exam in the academic year of 2019 and 2020 and are attending the same course this academic year. This would allow us, using their academic success on other courses for control data, to draw a more detailed comparison between the two vastly different approaches to knowledge evaluation. I hope you had a nice presentation. If you're interested, please check the complete paper, and now I'm available for further questions.